Okay, let's dive right into this explainer. Every single day we rely on electronics, sprawling infrastructure, the jewelry we wear, all of it. But there is a massive, highly complex, and honestly, a pretty hidden shadow side to the metals industry. We're talking about the staggering environmental footprint of what's left behind. When we think of mining, we almost always just picture the valuable end products, right? The gold, the copper, the lithium. We rarely, if ever, picture the collateral. So, to really understand this industry, we first have to wrap our heads around the incomprehensibly massive scale of waste generated just to extract even the smallest amounts of valuable minerals. I mean, we aren't talking about a few dump trucks full of dirt here. We are talking about literal mountains of earth being moved, chemically processed, and permanently altered. And how mining companies actually manage these colossal waste streams? Well, that is easily one of the most critical environmental challenges of our entire generation. All right, Section 1, Mountains of Mining Waste, Defining the Debris. Let's break down exactly what we're looking at. To hold companies accountable, the SASB standards require incredibly precise definitions for these literal mountains of material. Let's take waste rock, for example. Now, the absolute crucial point to remember here is the phrase, at the time of mining. Waste rock isn't just plain dirt. It's rock that simply isn't profitable to process right now. We're measuring this stuff in millions of metric tons, and because it contains low concentrations of those target minerals, it can still chemically react with the environment. That is exactly why companies are strictly required to report the total weight of the waste rock they generate. Now, tailings, they are an entirely different beast from waste rock. While waste rock is often just, moved out of the way, tailings are the complex byproduct of the actual mineral processing. Once the rock is crushed up and the valuable metals are extracted, what's left over is this slurry of pulverized rock, water, and very often the heavy processing chemicals themselves. Because of their unique physical and chemical nature, tailings have to be managed under super strict guidelines, like the Global Industry Standard on Tailings Management. And because these materials have totally different risk profiles, the SASB metrics step in to force companies to transparently report these immense waste streams. The baseline requirement, they have to disclose the total weight of non-mineral waste, the tailings produced, the waste rock generated, and the hazardous waste generated, all tracked meticulously in metric tons. It completely removes the ambiguity. It gives investors and, honestly, the general public a clear, hard, quantitative look at exactly how much waste a mining operation is leaving on the surface of the earth. Moving right along to Section 2, the hazardous chemical threat. Invisible but toxic. So, stepping away from the unimaginably massive physical waste for a second, we hit a microscopic but absolutely deadly threat. To chemically separate those valuable elements from the raw ore, using specific techniques like leaching and flotation, companies have to rely on highly toxic raw materials. We are talking about heavy hitters here: cyanides, sulfuric acid, hydrochloric acid, and even mercury and lead. Improper storage or disposal of these chemicals presents a severe long-term threat to human health, especially when you consider the terrifying potential for contaminating the surface water and groundwater that local communities rely on for drinking and agriculture. To prevent catastrophic contamination scenarios, the industry must rigorously report any significant incidents, spills, or poisoning events tied to these chemicals. And what exactly is a significant incident? Well, it could be seepage from a tailings facility that contains a really dangerous concentration of these hazardous raw materials. SASB practically demands that mining entities document these incidents to the letter, especially if they end up impacting local biodiversity, require massive environmental remediation, or, worst of all, cause harm to employees or the surrounding communities. That brings us perfectly to Section 3, acid rock drainage, a ticking time bomb. Now, what makes this next environmental hazard so incredibly pervasive is that it actually happens naturally when mining exposes certain buried rocks to the open elements. It's a chain reaction known as acid rock drainage, or ARD. Here's how it works. When surface water or shallow subsurface water encounters mining overburden that contains sulfide minerals, boom, oxidation kicks in, creating highly acidic runoff. This runoff then acts like a solvent, dissolving heavy metals and basically turning the water into a toxic, lethal threat for humans, animals, and vegetation if it's just left completely unchecked. Because this is such a severe, long-lasting threat, SASB requires companies to look into the future. They have to report the exact percentage of their mine sites where this drainage is predicted to occur versus where it is actively being mitigated or remediated. A site gets flagged as predicted to occur if complex computer simulations or acid-base accounting evaluate that ARD is likely to form. This is absolutely brilliant because it keeps companies looking ahead, proactively planning, rather than just scrambling to react after the local water is already poisoned. So, what do they actually do about it? Well, companies use these specific active mitigation methods to literally neutralize the acid-producing bacteria and shield the surrounding ecosystems from irreversible damage. This might mean securely covering the sulfide-bearing minerals to stop that initial oxidation dead in its tracks, mixing in acid-buffering materials to balance the pH, or actively capturing and chemically treating the wastewater. These steps are absolutely critical, and they represent massive material costs that these companies have to budget for, both during the mine's active life and long after it shuts down. Okay, Section 4. Tailings, Facilities, and Catastrophe. The ultimate high-stakes scenario. Now we are looking at the big one, the physical structures where millions of tons of wet, chemically treated tailings are stored indefinitely. Tailings storage facilities, or TSFs, are literally some of the largest engineered structures on the planet. And let me be clear, if a tailings dam fails, the ensuing catastrophic release is not just a localized spill. We are talking about a tidal wave of heavy metals and processed chemicals that destroys absolutely everything in its path. It leads to incomprehensible financial losses, permanent environmental damage, and an immediate, non-negotiable loss of the company's social license to operate. So, to impartially assess this massive risk, SASB mandates a highly detailed tailings storage facility inventory table. It's intense. Companies must disclose exactly how the facility is built. Are they using downstream, upstream, or centerline construction methods? They have to report the maximum permitted capacity and the current amount of tailings already stored there. Crucially, they also have to disclose the facility's consequence classification. This is a metric that, bluntly and without sugarcoating, categorizes the potential severity of a failure. Which leads us straight into our final section, Section 5, Accountability and Emergency Response, Preparing for the Worst. Because the stakes with these facilities are just incredibly high, internal checks, they simply are not enough to maintain strict accountability. You can't just grade your own homework here. The crucial point is independence. Third-party experts must evaluate the structures to identify any material findings regarding safety, entirely without any internal bias. SASB asks companies to publicly report the date of their most recent independent technical review. Because think about it, if the very engineers who built the dam are the only ones checking it, the risk of a fatal blind spot is just way too great. And the framework demands rigorous follow-through. It's not just about finding problems, it's about fixing them. If an independent review does find a material safety issue, the SASB metrics require the company to publicly disclose exactly what mitigation measures are being taken to reduce the risk to a level as low as reasonably practicable. It essentially forces a direct, fully public line of sight from discovering a problem to actively funding and implementing the actual solution. No sweeping things under the rug. But let's be real, prevention isn't always perfect. That is exactly why companies must have incredibly robust, site-specific emergency preparedness and response plans. And I don't mean just a dusty binder sitting on a shelf in a manager's office. Companies have to actively test these plans. They need to run frequent evacuation exercises and intimately coordinate with local stakeholders, first responders, and public agencies. If that dam breaks, the difference between an expensive environmental cleanup and an unimaginable human tragedy comes entirely down to the speed and effectiveness of this local response. As we close out this explainer, we really have to ask ourselves about the permanent geological footprint we are actively leaving behind. Every single wind turbine, electric vehicle, and new smartphone comes with a hidden cost, a mountain of waste rock, a literal lake of chemical tailings, and a multi-generational commitment to mitigate acid drainage. By demanding standardized metrics and complete transparency, frameworks like SASB force this massive industry into the light. But the next time you go to upgrade your phone or buy a new gadget, you have to wonder, are we truly prepared to manage the toxic mountains we leave behind in the pursuit of our modern world?